So I think it's also important to know where we are in terms of the industry. Obviously, it's my only it's only my perspective, but I thought, when I was reading through this chapter today, I quickly glanced through this entire chapter, and a lot of stuff is being basically just talked about here. Actually, this notebook has more detailed code than the book itself. But I thought this is quite important to kind of keep in your mind. I think we are like ML ops has evolved through three stages of maturity. ML ops 1.0, basically just manually building, training, tuning, and deploying models. Now, I mean, I wouldn't even call this ML ops, to be honest, but and this is where the data science education starts to fall behind, unfortunately. I think the most of the data science education still focuses around this ML ops 1.0. And I think this is where majority of the companies are. I think this is where the big companies, the fans are. And this is where the majority of companies are trying to move towards, which is automatically run. Well, the 2.0 is manually building and orchestrating model pipelines, and ML Ops 3.0 is automatically running pipelines when new data arrives or code changes from deterministic triggers such as GitOps, or when models start to degrade in performance based on statistical triggers such as drift, bias, and explainability divergence. I think some companies will never get there, just because they don't have the means to build all the infrastructure needed. But perhaps medium to big companies are all like moving towards this. I just see that being the trend. And as you know, SageMaker pipelines, introduced many major features half a year ago. I think, more and more companies are probably just going to jump onto SageMaker pipelines, to be honest. That's what I feel like. And I don't think from the, a quick overview of Google's platform, I think I would say SageMaker is quite ahead in this game so far. So, and this is kind of what we're trying to learn. But I would say, somewhere between 2.0 and 3.0 is where we are. But to get to 3.0 is, I would say, is almost impossible by yourself. You would have to be in a company, and to get the data that constantly flows in, then you can set these triggers and detect drift and bias, or degrading performance. So this is not something to be done in a prototype, for sure. So yeah. Okay, and so the entire pipeline, just for a quick overview, we are doing data ingestion, data analyzing and validating, feature engineering and selecting, model training and tuning, model analyzing and versioning, model deployment, and monitoring. So that's kind of a quick overview of the entire pipeline. But obviously it's not trying to orchestrate anything. It's just a straight pipeline, as a straightforward diagram. And what corresponds, I think the graph below corresponds to this one on top. And so what we have been doing is using S3 and Data Wrangler. Well, I guess we didn't use Data Wrangler, but we used S3 for data ingestion, right? That's where we store the data. We used SageMaker Studio notebooks for analyzing and validating. We used SageMaker processor to do some processing, and we use SageMaker to train the model and tuning. We are also using SageMaker debugger for model analyzing and versioning. And eventually you deploy on SageMaker endpoints or model registry. So yeah. Any questions up to this point before we continue the process today?
Seems straightforward now.
Okay, so today we're just going to keep going forward, as I think we were short on time in the last two sessions. So we're probably going to spend less time, for you to play around with the notebooks, but more time just walking through the notebooks, just so we're on our schedule. Okay, so previously, I think we had a question in terms of in the 07 notebook. I hope you still have those open. And so previously, I think we had a question what this was in terms of creating a trial experiment. So it turns out, I think in the book, it says it's actually the same thing. It's basically for tracking pipeline lineage, so that you have all the parameters, being tracked. And let me just, yes. So the experiment and the trial are set and defined together. So it's basically for us to track our pipeline lineage. I think that was one of the questions I had in terms of what was the purpose for the trial. Okay, so last time we stopped at, I think we finished the training step. Let me go to that. I think we, well, first of all, quick recap. We talked about, 4 steps that we want to define. Let's go to the top. It was 4 steps. The processing job steps, the training job steps, the conditional steps, and the transform job steps. And let me see, actually, yes, the processing step, the training step, the evaluation step, and the condition step. These are the 4 steps that we need to define in order to feed them into our pipeline. Okay. So let's go to the training step. Okay, so this is where we, I think, finished, I believe. Correct me if I'm wrong, but we had the training step defined, and we're moving towards the evaluation step. So first, we develop an evaluation script that will be specifying the processing step that will perform the model evaluation. The evaluation script will basically load in the model, read the test data, issues a bunch of predictions against the test data, builds a classification report, including accuracy, saves the evaluation report to the evaluation directory. And we have this evaluation processor. So, and this is interesting because we are also using sklearn as a processor for evaluation process. And this, again, is the framework version or the library version of sklearn. So it's still using 0.23.1, I guess, in the row. Process instance type, we had it here. Process instance type as this, and we had our process instance count as 1. So I think this was just run through a maximum runtime in seconds of environments. So we set our default AWS region here, and the region, I think it's, for me, it's US East 2 or something like that. US East 1 or US East 2. Maximum runtime in seconds, so that's 12 minutes. I don't know why this is set. Oh, I guess this is not the training step, this is evaluation step. So 72, well, 12 minutes is probably fine. Actually, it's 120 minutes, 2 hours.
Before we go too deep, just a quick sidebar question, Wencheng. I know you've done scikit-learn pipelines. Is this SageMaker function for scikit-learn that's built into SageMaker? It's from sagemaker.sklearn.processing. Is this in any way similar to scikit-learn pipelines? Just a sidebar question.
Yeah, it is definitely possible. Let's look at this SageMaker.sklearn processing. Maker processing.
sklearn processing.
SK processing. SageMaker. Processor.
Yeah, it handles SageMaker processing, Amazon SageMaker tasks.
Yeah, I'm trying to find the source code if there is source code. SageMaker. So there is right here, scalar processing, script processor. It's from the process SageMaker.processing. So SageMaker.processing. Right here. The answer is no. It's inheriting from the processor, SageMaker processor itself. And this processor, let me see, is about 1,200 lines of codes. And does it have sklearn?
Scikit-learn is a massive ecosystem, so it's got to be calling scikit-learn process somehow through some sort of API in these 1,000 lines of code. It couldn't be replicating all of scikit-learn here.
Script processor. Let's see what's going on here. Script processor. No, I don't see sklearn. And it's not importing the library either. If it's using sklearn, it must have sklearn imported. I don't see that. It's probably calling some other libraries, workflow, parameters, entities. Yeah, I don't see it. I don't see a sklearn pipeline. Normalize outputs. Processing job. Initialize a processing job. You know, I think what's happening is this is not even doing the job itself. You see what I'm saying? This is just sending to a SageMaker Docker container to process the job. So the Docker container itself is handling that. And this is just sending that to SageMaker. Provides functionality to start, describe, and stop processing job. So this is only calling a SageMaker session. There you go. So that is not visible. It's not visible to you. What's going on the back end, how they build it. Maybe Boto 3 would have a better answer. Not sure because Boto 3 create context, delete, describe, list, send, update.
Because even though it is calling scikit-learn processor, it doesn't, if you're calling it through these process jobs, going to a SageMaker container and so on, you're going to be limited to scikit-learn, running scikit-learn functions that are templatized here, as opposed to just about anything. Going back to our early conversation where everything's just, you're using XGBoost or straightforward machine learning frameworks. You can't customize this.
Yeah. So in the end, you're just basically, I mean, think about it. In the end, everything, this is just the highest layer. Think about it this way. This is just a layer that sits on top of all the AWS resources. We don't know how AWS wrote these resources on the back end, but we do have an quote unquote open source library that calls these resources. So this is just a layer, an API layer that sits on top of all the resources that we can call. And this is infrastructure as code, right? Boto 3 is basically the AWS SDK for Python, where you can call all the resources as long as you pass in your credentials. We don't know how these resources are written. We don't know how SageMaker is written on the back end in terms of how they can spin up, these containers. So that's their trade secret. This is just an API layer that sits on top of all the resources that are not open sourced. They only open source this library for you to use. That's it. If that makes sense. Yeah. So the answer is it might. We don't know what's going on within how within SageMaker and how they call like what's written in the container basically. Okay. Any other questions? Okay, so let's keep going. We use the processor instance to construct the processing step along with the input and output channels and code that will be executed with the pipeline invokes. When the pipeline invokes pipeline execution, this is very similar to a processor instance from method for those familiar with the existing Python SDK. And okay, and you can define evaluation reports with the property file, and you can select that. Oops. Okay. Output name metrics evaluation.json. So you can have an evaluation.json outputted. And I think I have this entire evaluation step is defined here. And it's defined using the processing step class as it's considered as a processing step. So we have the name here, we have the evaluation processor defined right here with the sklearn processor. That's just passed into this. And we're using this code, evaluate model metrics.py. Let's look at this, evaluate model metrics.py. Can anybody hear music in my background?
Nope, I can't hear it.
Okay, great. Because yeah, my neighbor or so yeah, my neighbor is playing music. That's well, I'm glad you didn't hear it, but I'm hearing it. That's fine. Okay, so I think it's also supposed to run through this code, this .py file. Evaluate model metrics, this or parse or predict. What's this? I wonder, oh, this one, process args. Okay. Yeah, so this is basically just running through this function, process args. Process args, process, yeah, this one. Okay, loads the model. And you have a test data path right here. And you have the test review data sets passed in. And you have a y test, y actual, and you have a plotting function in the middle. And you have the accuracy score calculated from the test data set. Then you plot that. Then you evaluate it. So that was basically, okay, I see. So you can pretty much just run, define your own code. I see. So Mash, to answer your question, this sklearn process, it just means you need to process something in sklearn, but you need to define everything here. And this is where sklearn is being used. If that makes sense. Yeah.
It does.
Yeah. So
Thank you for this. I initially got confused, and it's when I saw this and you pointed this. This is what in the class session, Terrence, if you guys can, if you recall as well, he spent a few minutes walking through this .py file, evaluate model metrics.
I think it was probably the previous one. It was probably this one that he spent time on, if correct me if I'm wrong, but I believe it was this one.
Maybe you're right. Yeah.
Yeah. And this one was the one that was fed into the previous one, the data.
Yeah, I could have thrown the evaluate model metrics as well because it calculates the accuracy and then it plotted it on a simple chart as an output.
Yeah.
And it comes later on though.
So there you go. So the processing step. So this is the data processing step. It could have been named better. I would definitely just name it as data processing step and the evaluation processing step and the training step and condition step. So, but you see, this refers to this file. And it just runs through the entire thing with this process args. So this process function is the last function and it has all the args. I suspect all the args probably come from current host, current stuff, future. Yeah, so it comes from all the parameters that we defined here, actually. So these args are basically passed in. So SageMaker will pass in the arguments. So some of them are here. So the arguments from here are fed into this process func. So current host, we don't have that here. Feature store offline prefix right here. And args output data. So if we don't have it here, it might be here. Output data. I don't see output data here, but we have input data here. Input data, yes, we have input data here, right here. That's the args output data. I didn't find that. But this parse args basically just parses in all the arguments that we passed in. And so but this is where you define all the processing steps, right? And remember, I remember he said, I think his name is Chris. Chris said, this is supposed to be the production code that goes into your pipeline. And that's what it should be, right? Because in the end, you need to put something into here because this class is not going to be able to take in a notebook, right? Because it needs to process something. It needs to process a .py file. And that's what it's using to process. And it's taking the arguments that you feed in. So not only you're defining all the parameters, you're defining how you want to process your data, right? And the processor is just a sort of an instance. But the processor itself is only defining the sklearn library version and your row, which is your resource row, I believe, and your instance type and instance count and region. So those are metadata that defines your processor. And but it itself doesn't define anything regarding to how you want to process your data. That comes from this pre-processed scikit-learn text-to-BERT gigantic file that has 600 lines of code. Okay, and if you recall, this is where the TF transform comes in, right? So if you want to match this with the TFX pipeline, this is where the TensorFlow transform comes in, where you have to kind of just use TensorFlow or TensorFlow transform to process data. Whereas if you use sklearn, then you can use pandas and sklearn to transform your data, which is something that more data scientists are familiar with, right? So, but of course, I think it's using some TensorFlow stuff as well, such as TF records, maybe. I believe that was the case. Maybe not. TFX. Nope. Okay, so not even TF records here. It's just pure sklearn train test splits and func tool. Okay, what else is it using? Class objects. So it's just as type. Using as type, D types. Okay, that's using pandas, even though it's not importing the library. That's just defining the feature for feature store. Inputs, yeah. Okay. Tokenizer, that's using the tokenizer from the Hugging Face transform inputs. Okay, this is the TF record. Okay, so it is using TF. So I don't know why it's not importing the TensorFlow function. Perhaps TensorFlow function is let's do a quick search TF. Maybe TensorFlow is already installed within the container itself, because in the end, this is done in a SageMaker container. So that SageMaker container probably already has TF TensorFlow. There you go.
Line 26, yeah.
Right here. Yeah. So it is imported. It's only imported. Yeah, here. Yeah, I didn't read. I mean, I thought this was yeah. Anyway, but it is here. TF Keras and TF and pandas. Yes, pandas is imported. Okay, that makes sense. Line 26. Thank you, Deepai. Great. Okay, so back to the evaluation step. Okay, so we're using the evaluate model metrics.py, and we have two processing inputs using the processing input class. And this comes from the training step properties model artifacts, S3 model artifacts. So basically, we're feeding this from the training steps model artifacts, and dump that into a destination that's in a container, and another processing input class that takes in raw input data. Okay, raw input data from S3 from the processing step with S3 inputs, S3 URI, and the destination is here. So I think these are like pretty fixated. Maybe this parameter can be changed, but if we need to replicate this or do another project, these should probably stay the same. These will probably stay the same as long as you name this as training step and processing step. The other thing, okay, you have the output as processing output class, output name as metrics, S3 upload mode, end of job. So basically only at end of job you upload to your S3 bucket, and from the source directory of this, which is also within the container. And your job argument is max sequence length, that's 64 for bird model. And we're using the default value, property files, evaluation reports. Okay, so then we are feeding this evaluation reports instance into this. Now, for those of you who maybe are not as familiar with, what's going on, why are we having an instance, then we feed into something else. And this goes back to Python OOP, object-oriented programming. And a lot of times you want to define an instance of a class first in, using the parameters that you want. Then you feed that instance into a variable, and this variable contains the instance of this class. But if you say, like if I have an evaluation report 2, and I could totally define, another instance with name equals to evaluation report 2, output names, I could have the same thing, and you get what I'm saying. Basically, this becomes another instance that could be fed into this, right? So what it means is that this parameter itself only takes in an instance, which needs to be defined already before this step. Okay, so, and we also have the model metrics defined here. Okay, so evaluation step, model metrics. So the model metrics, we have the metric source right here, evaluation step, arguments. Okay. So this is where, so we're taking the evaluation step and put it here. And this is, well, actually, this is just taking the evaluation steps arguments, S3 URI, and feed that into the stream itself. And that was it. Let's see if we can find this. Okay, so let's open up another tab. S3 buckets. Okay. Can we find something? S3 evaluation.json. Let's see if we can find it here. Okay. Nope, not in this one. Rule output, profiler output, profiler output. No, that's not the debug output. Training job ends. Debug output collections. Not this one. Output. No. Events. Those are just events. So, okay. So, SageMaker. Training. Could be in this one, outputs, metrics. There you go. All right, found it. Great. So it's this. Let's download this to see what's in this one. Desktop. Okay. Okay. It actually just says accuracy 38%. Nothing too crazy. Okay. And we have a confusion matrix. Let's see what it looks like. Cool. So we have the confusion matrix, true label 21, predicted label.
So if I may, I don't mean to jump ahead, but so these are set up, these arguments and everything is set up in notebook 7 with all, and then it is run in notebook 8. So this confusion matrix and some of the others are actually show up in notebook 8.
Yes, great, thank you, good to know. Okay, so it's just printing out this model metrics instance. Okay, so we can also register our model. We use the estimator instance that was used for training step to construct the instance of register model. Results of executing register model in a pipeline is a model package. A model package is a reusable model artifacts abstraction that packages all ingredients necessary for inference. Primarily, it consists of an inference specification that defines an inference image to use along with an optional model weights location. A model package group is a collection of model packages. You can create a model package group for a specific ML business problem, and you can keep adding versions and model packages into it. Typically, we expect customers to create a model package group for a SageMaker workflow pipeline so that they can keep adding versions and model packages to the group for every workflow pipeline run. Now that makes more sense, right? If you recall what we did for TFX on GCP, we were just using, cloud buckets for, different versions of models. But SageMaker is going fancy by providing us an entire, platform or library that would contain all your versions of, models. And it's sort of automating some of the processes, and you can just all you have to do, I guess, is just add on top of it, add more versions on top of it. And that's, definitely more advanced. The construction of a register model is very similar to an estimator instance's register method. In particular, we pass in the S3 model artifacts from the training step train properties. Training step properties attribute matches the object model of the described training job response object. Okay, so we have the model approved status. Notice, we're defining a lot of these parameters all within the class called parameter string. So parameter string, parameter integer, and we define what it is. So we call it name equals to model approval status, default value pending manual approval, deploy instance type. Okay, so we had, I believe we had processing instance type, but now we are defining the deployment instance type. So what is basically hosting your model? You need a machine to host your model, and that flavor is, or the default flavor for your model, for hosting your model, is ml.m5.4x.4x large. So notice it has an ML prefix, at the beginning. So which means we're probably using something, with basically in this list as well, right? And if you look into, bunch of you see to AWS. So if you look into like EC2 instance types, right? You don't see ML prefix here. And you see M, A1, M4, so which means these instances are probably, specifically built for ML purposes, and I didn't actually notice that in the beginning, but it seems like they're probably optimized for ML purposes. And of course, a lot of them would have, GPUs. So, okay. So the default value, so the default hosting instance is type is ml.m5.4x large. And let's just double check what it is. ml.m5 4x large. 4x large. So it is it has 16 CPUs, but 0 GPUs, and 64 gigabytes for memory. Now that makes sense actually, because I don't want, I don't need GPUs to host my model or deploy my model. I just need GPUs to train, I guess. Okay, so deploy instance counts. Okay, so default value is 1. And so we're only deploying this to one instance or one server. Okay, and we have our model package group name right here. I wonder if that's also in our S3 bucket. Model package group. I wonder what this is. Reviews, parts. That's for data. That's for Athena. That's for bias report. Query results. That's the query results from the Athena. This is the feature store. This is the scikit-learn. I believe this was the scikit-learn. Yeah, scikit-learn input outputs. We're also saving the code right here. Those are the outputs of the. Okay. So I guess that is not. What do I have in here? Doesn't have anything. It doesn't have anything. Okay, so everything's under here, which follows my username most likely. Default 162.3267. It doesn't. So how's this defined?
Might be some version of time.
Could be. So notice I didn't start the app or choose the instance type, right? And this is already started. I shut it off, and this was just started. 1806 GMT. So you didn't even have to start. As soon as you click into this Open Studio, it's automatically started. I think we mentioned about it. Yeah, I have no idea why that bucket is named that way, but anyway, it is what it is. Okay, so model package group is defined with this name, 5527, which is the timestamp. So this is the timestamp, and we have our inference image URI retrieving this. So, okay. So we have tensor. Oh, I see. This, and I think we were trying to check if we have the, the ECR. Did they save anything on our ECR Elastic Registry elastic container repositories and none. So that means this is probably from, yeah, this is most likely from AWS's own repository. And inference image URI. So basically we're taking this TensorFlow inference 2.3.1 CPU for inference purposes. So we're using this image, this container image to spin up a container. And that container specifically is for inference. And that container would have TensorFlow installed, and the version would be 2.3.1, and that container would be located in the region that you specified. And I see, and it will have the instance type that you defined right here. That makes total sense. So basically, it probably has AWS probably has a lot of these images, in their repositories. And as soon as you're like define the inference image URI and you hit go, you execute it, and it just spins up one of these images with the instance type of your choice, which is pretty cool. They really did a lot of innovation with regard to data engineering. It's fantastic. Okay, so register step. Eventually we have this register model step. And we'll just call it register model. Estimator, I think we already defined it. And as the model itself. Oops, did I skip that? Oh, right here. So that's the estimator we defined. It's basically a TensorFlow model with the instance type, train instance type and train instance count, and a bunch of hyperparameters for training purposes. Okay, so okay, going back here. Okay, so we have inference image URI right here. This one is right here. So in this register model, register step is definitely fed into the entire pipeline, once we initiate the pipeline. So nothing is initiated at this point. Remember, that's the same thing for TFX pipeline, right? We build a bunch of components, then we eventually initiate everything together. Okay, so model data training step properties model artifacts S3 model artifacts. Okay, that's just basically taking the training steps. So it basically means, okay, so let's say now the pipeline is initiated. We take the training steps, properties, and artifacts, and feed that into the register model or register step. And that's where it's fed in. But this is not pre-calculated. This is probably generated after the training step is run through. So sort of like each of the previous steps, artifacts would feed into the next step. Similar to TFX pipeline. Content types, we're just basically defining this as application JSON lines, and that's probably just AWS definition. So if you're doing another project, I would just follow this, copy paste this format. Deploy instance type, again, we talk about that. We're just using ml.m5.4x large. And okay, there's some transform instance. I don't know what we're transforming here. I don't know why we need a transform instance here, but that's fine. Our model package group name is called this, BERT reviews. model approval status. So model approval status would have to be this, and it has to be, and there is a status. Apparently, there's a status that's called pending manual approval. So if you read the book, yes. Once the model is registered, our pipeline requires a manual approval step to deploy the model to staging. So this is where a human in the loop starts coming in. You know, basically, if this pass the the requirements, and then it would need someone manually approving the step. And then this model will be deployed to staging, the staging environment. Then after that, what's happening is you would need to test your model. So there's a testing phase. I think that's also mentioned in the book. Test. Yes. We can approve models through the SageMaker model registry, either manually through the SageMaker Studio UI or programmatically through our notebook. Approving the model will automatically deploy the model to a staging environment for testing. Our pipeline then requires a separate approval to move the model from staging to production, which means, okay, so there are a couple of things here. First, we need to approve the model manually or programmatically. Second of all, after we approve it, the model gets pushed to a staging environment for testing. Now, then it needs to be tested. The model needs to be tested, and so on and so forth. And then it requires a separate approval so that your model gets pushed from staging environment to the production environment. If the testing is successful, we can programmatically approve the model to staging using the following code, which is what we did, right? So, which means we don't need to manually approve the model to the staging environment. But I guess, that it definitely makes sense for humans to come in and be like, hey, this model is good to go. So human in the loop is certainly necessary, at least in this step, from the staging environment to the production environment. That's what I would say. Okay. Any questions up to this point? I know I've been talking a lot, but yeah, it's just a lot to talk about. Any questions? You good?
Not a question, just a comment.
Yeah.
No comment either. What you just showed to me seemed a lot like what I had initially said at the beginning, where it boils down to just these few processes, whether they be for image recognition, so on and so forth. But I can't seem to verbalize it right.
Okay. Yeah. Are you talking about like it could be different processes for different tasks?
Yes, but these tasks are very specific within SageMaker.
Yeah.
I mean, SageMaker this is what you're showing as we were going through this, and by itself, there's so much more rich capability here.
Mm-hmm.
There are small companies, startups like Weights and Biases that does model management, deep learning model management, and a whole bunch of others, Verta, and so on. These capabilities built into SageMaker does all of it and quite easily.
Mm-hmm.
So it makes some of those other companies that have been around for a few years their capabilities entirely moot. Why bother getting yet another vendor when you can do it all this in AWS?
Exactly. That's why I was like, there's no data science. It's just data science on AWS. There's no data science on your local laptop. That's what I meant. Yeah.
You don't need that. You just, as long as you're using SageMaker and you understand how these pipelines work,
Yeah.
just pick the use case, whether your use case is reading contracts,
Yeah.
LP involving contracts, or some kind of vision or customer vision counting that you're going to use in supermarkets.
Yeah.
They'll do it.
Yeah. And then you can just, and to be honest, you don't even need SageMaker Studio anymore, right? Because once you're able to develop and test all the codes on VS Code, you can still deploy all these resources just from your local laptop. So your local laptop becomes an interface to infrastructure resources. It becomes an interface to prototype some of your code and just directly deploy that to a platform like AWS. So yes, of course, you still need your laptop, but it's more like an interface or a doorstep towards a platform, a cloud platform with a bunch of resources and that you just call, right? So yeah, so and then you don't need SageMaker Studio anymore because you're still calling this instance, that instance, the feature store, spinning up the SageMaker containers and so on and so forth. So
agree 100%. Open question to everybody here. Does anyone else feel like if this is the way we're going to be doing computing, this is the way we're going to develop applications and solutions and capabilities and so on, that this skill set is really the new technologist? This skill set is the new AI engineer, call it whatever you want, or just the new IT person skill set, the information technology, as opposed to like, get me my bloody laptop. Does anybody else have any thoughts? Like, is this it?
I'm seeing the same thing as
Yeah.
well. Well, at one point, data science was the thing. Matter of fact, I had a conversation with an Azure data rep the other day, and he said the same thing. Data science, there will still be people that are doing that and building, the physical models, but it's this side of the house that is lacking. This side of the house that actually introduces projects into production, right? And then keep them in production. The other side, there'll still be people within the company that are doing that, but this side is where you need the majority of you people.
yeah.
He didn't even encourage me to even look into, and to be honest, he actually pushed me away from the whole data science aspect of it and said, this is where you need to focus, on this side of the house. And I'm sure Azure has their own processes around, some of this. I don't know if it's as mature as AWS. I haven't really dug into it yet, but I'm sure they have pipelines as well.
I think yeah, no, to your I don't know if he knows your background, but like to your background, I would certainly agree with him. Like because you come from a database data engineering background, like
Right,
yeah,
right.
there's no reason for you to go into data science field for sure. Yeah, it like data engineering pays the highest currently. I think alongside with machine learning engineer, but companies need more data engineers than machine learning engineers and data scientists. So when you start a startup, you need two jobs or two titles. You need you need a software developer first. Don't even
I agree.
you don't even need a data engineer at the beginning.
Right.
But then afterwards, you need a data engineer if you're dealing with a lot of data. Then you just build a bunch of stuff, and if you want to if you want to use some data, then you hire a cheap data analyst. Then you use some of the data and do a bunch of stuff, and maybe that data analyst will grow into data scientist, or data science engineer, and you using more data and build more data pipelines and model pipelines. You don't need machine learning engineer for smaller companies, small to medium sized companies, because a lot of these companies don't have unlimited ML use cases. Unlike huge companies, the fans, they have unlimited amount of ML use cases where they would absolutely need specialists, such as ML engineers, to only focus on productionizing ML systems. Otherwise, you don't. So that's how I see people hire people, and that's how that's how we are hiring at some clients companies, and that's how I'm probably going to hire with my startup down the road. So yeah.
Which is why one of the largest grocery retailers in the United States uh, feels stuck right now because they hired 20 super data scientists with all with PhDs from Stanford, Carnegie Mellon, Oxford, and so on, trying to figure out how to begin to use them and task them to come up with the compelling use cases for a grocery supermarket chain. Uh, and the best they could come up with was, let's use vision. That's not what this is. I don't think that will help. I think it will be a lot easier for a grocery store supermarket to have these sorts of pipelines connected to each of the different classes of product and identify what's the right amount of that product that's going to need to be sold in any given store, and do it even better, and tie that to all sorts of other macroeconomic and customer demographic data, and keep it real time to, as customers come in through the door, that's going to change and trigger different predictive models because you've got the right model management, and that will change based on how many customers are coming through the door at any given time, along with maybe the temperature. I'm just making this stuff up, but that's going to be a lot more compelling than say, oh, let's use vision and come up with something interesting and augmented reality stuff.
Yeah, because that's going from, that's definitely a trap that I've seen many, many times. You don't ever go from algorithm to business problem. You always go from business problem, then you find whatever can solve that.
Exactly.
And maybe algorithm, maybe not. And then again, right? So it goes back to the question, like, what if you don't need machine learning? Then like, well, and your title is machine learning engineer, are you gonna just sit there and just be like, well, I only do machine learning, sorry guys, right? So no. The answer is, only, very few, I see very few companies would need to hire specialists like that, because they have way too many machine learning models to work on, and they have all the infrastructure ready, like machine learning ready, and that is a high requirement. And the more I study this, the more I realize machine learning is also a high cost, high risk, high rewards. path that's you know, it's high reward, but it's high cost and high risk. So you know, definitely take precaution for that. Yeah. All right, so let's keep going. Create model for deployment step. And okay, so we have, again, our model name is BERT model, format timestamp. We have our, okay, so we're directly importing this model class from SageMaker.model, and model equals to model. So we're instantiating a class with model, and model name, inference image URL. So, okay, this inference image URI is being passed around in different places. We have our SageMaker session passed here. We have a row here. We have model type, model data from the training step, and create model inputs, deploy instance, create model steps, create inputs, model, create model. Interesting, create model for deployment step. Okay, so register model. So we have a step for registering the model, and we have, so if you look into this, we have a step to register the model, and we have a step to create a model. And those are all, and we have the a step to transform. Now, that all sits within the condition, after the condition step, right? So if the model passes the condition, we do these three things. Else, we don't do anything, right? So, because it's not meeting the condition. All right, so let's keep going. Conditional deployment step. Finally, we would like to only register this model if the accuracy of the model as determined by our conditional step or evaluation step exceeded a given threshold. Condition step allows for pipelines to support conditional execution in the pipeline DAC based on conditions of step properties. Below, we do the following. We have our minimum accuracy value set as 10%. So as long as it's past 10%, we're good. I think last time, well, the last metrics file, JSON file we checked was 38%. So that passed. That's why I think we had a model. And let's check that model in our S3 buckets. What is this source? Okay, so our models are in here. I believe we have outputs. Right. So today is July 21st. So this model went through, and it's about 838 megabytes. And if we look at the pipeline, this was done 2 hours ago. And our graph, this is our graph. This is the parameters that we're looking at here. Okay, and we can restart the execution if we want, and it was succeeded. It was successful. Okay, so condition, and we have the condition class instantiated here, condition greater than or equal to the evaluation, sorry, the minimum accuracy value. Where is that? Okay, the right is minimum accuracy value. The left, so the left is probably the condition name, and the right is the condition value. So it needs to be larger, greater than or equal to the right value, I guess. That's okay, that's pretty self-explanatory. The step is the evaluation step. JSON get evaluation step is defined right here. So we had the evaluation step here. Okay, so that is being passed here. If we have our evaluation report being passed to here, and minimum accuracy value. Okay, so we have another. So every parameter needs to be passed into this parameter float, integer, or string condition step. So this is where we pass in the steps within this box, right? So we had register step, create step, and our condition is this minimum accuracy condition. So we pass this condition to here. So let's say we have more conditions. Then we can have more conditions defined here. You know, it could be like maximum accuracy. I mean, we wouldn't have that, but I'm just giving out a case example, I guess. And you would, you know, define this greater than or equal, or I guess it would be smaller than then you would redefine, you know, everything here. And this time will be like condition smaller than or equal to. You know, if it's 100%, it's probably not correct. So maybe we do want to have a 100% condition here. And it'd be like, you know, something got to be wrong if it's 100%. I don't know. But then you would pass it here, right? So maximum accuracy condition. So I suspect it will basically try to fulfill all the conditions right here. Again, this follows the code pattern of you just basically define a bunch of instances, or define a bunch of instances, and you pass into another wrapper that would take in a list of these instances as parameters. You know, that is a common pattern. Okay, so if steps, again, register step, create step. So if it passes through, we register the model, we create the model. Else step, we don't. Fail, end the pipeline. So, okay, define a pipeline of parameters, steps, and conditions. So finally, we defined all the steps, and we just need to define the entire pipeline itself with parameters, steps, and conditions. A pipeline requires a name, parameters, and steps. All the parameters using the definitions must be present. Steps passed into the pipeline need not to be in the order of execution. The SageMaker workflow service will resolve the data dependency DAG as steps the execution complete. Steps must be unique to either pipeline step list or a single condition step if else list. Submit the pipeline to SageMaker for execution, create pipeline. So this is where we define the pipelines, right? So what steps, parameters, and all that stuff. So we're calling the SageMaker, we're importing from SageMaker.workflow.pipeline import pipeline. Existing pipeline 0, existing pipeline response equals to SageMaker.list pipelines. So we're just saying, hey, do we have existing pipelines or not? And let's see. Yeah, I don't know why we don't have existing pipelines. So let's see. Let's see if we can just. Here we have, yeah, I created one pipeline. So, but I should have, I don't know why it says I only have one pipeline, because I should have more than one pipeline. I have 4. So that is strange. Okay. Existing pipeline response. Oh, It's because we're using the pipeline name. Okay, but that's just a name prefix.
I ran mine as often as you did. I have one pipeline from 14 days ago, two pipelines from last week, and I didn't rerun it today.
Huh. So but did this cell or block code return something different?
Hang on. No, it's the same, but then just said, here's the name of the pipeline.
Yeah, this is strange. Okay, but I'll probably investigate this further. Okay, so let's go through this. If existing pipeline is equals 0, then you just create the pipeline one time. Pipeline equals pipeline. So this pipeline comes from this, right? So this class. Then again, you're instantiating a class, a pipeline class. Name, pipeline name, parameters, input data, processing instance count, processing instance type. You're literally going through the entire set of parameters: max, sequence length, balance, data sets. So it literally is one-to-one match. Yeah, so I'm not going to go through these again, but again, these are all parameterized, right? We have used parameter float, parameter string, parameter integer. DPI asks question, is it because the existing pipeline is set to 0? No. Well, first of all, I think this SM, let's find out what SM stands for. It's probably defined.
SageMaker.
Yeah, it's probably defined. Yeah, okay. So I say, okay, so this is probably defined with one session, maybe. Okay, but this is SageMaker service, and it's using, and it's just basically a SageMaker session list pipeline.
So remember how you said you just write all this code and it kicks off the full workflow and so on?
Yeah.
You have SageMaker UI, SageMaker Studio UI, which gives you a web-based page where you can put in all of these parameters and everything else that's written in code. Just for those people who don't like to write it in code, they just like to see a nice, pretty well-designed web page. They do have that too. And so that's what this is doing. It's like driving stick or driving automatic transmission.
Yeah, I don't know why this is only giving me, so DPI, the answer is no, because it's calling this function to list the pipelines, and it's only just, it's parsing, and that function is parsing this dictionary and get the one pipeline. So this is only giving us one pipeline, and that's the question, why that is. Why is that? And I don't know. It could be the SageMaker session, maybe. I don't know. I usually don't use session. I don't know what session is. Okay, but yeah, it's only giving us one pipeline. Anyway, let's keep going. The steps. Okay, now we have all the steps right here. So we have the processing step, right? That's the data processing step. That we have the training step, evaluation step, and we have the minimum accuracy condition step. So minimum accuracy condition step takes in the register step and the create step. So even though we had these two steps previously defined, we're just feeding them into one condition step that's instantiated and named as minimum accuracy condition step. Okay. Any questions? I think we're pretty clear. So we have 4 steps, right? And this step includes 1, 2, 2 step. I don't know what that is yet, but it just includes 2 step in that condition step, and we have 4 steps in total, which is what we have here. 1, 2, 3, 4. And we have SageMaker session right here. Pipeline create row. So we have a specific resource row for our pipeline, and created pipeline with this, and you already created pipeline with that. Okay, so we just created pipeline basically like that. Okay, start the pipeline. Running execution, complete execution 0, list pipeline execution. So again, this is calling the SageMaker session and list the pipeline execution. And if it's executing, then you have, you add 1, and otherwise you just say completed execution plus 1. So it's basically checking the status of your pipeline execution. Right. My notebook just froze. Okay, wait for the pipeline to complete. So, okay, so, oh, right, we're here. If running execution equals to 0, so if we don't have any execution, meaning only allow 1 pipeline execution at a time to limit resources needs. So basically, we can have more pipeline executions, more than 1 running at the same time, but to limit the resources, that's why they just want to be like, if there are no pipeline executions running currently, let's start 1. Otherwise, don't. So that's pipeline.start. Parameter equals to dict. Input data, processing instance count. So it's basically passing these into a dictionary. Now, I think if you recall how we structure our package for TFX, these things should probably go into the config.py file so that you don't have to always type this again, right? And well, I guess you still have to type, but at least you're not repetitively typing the numbers like that. You're just typing the variable. In this way, it's less error prone, and also it's all sourced from the same file. Okay, so then, it's basically started. Pipeline.starts and started pipeline, ignore any warnings. So this will basically start pipeline. Now, then this is the cell that takes the longest time. So this one is, let's see what this one is. Execution response. Okay, it just lists the pipeline execution summaries, the status. I see. So this one actually, once this started, it starts to run, and this is just checking the status. And it should have, yeah. I would probably print, this print, or have more information than this. But yeah, while this is executing, you're basically just checking the execution summary, execution response, status, try this. If there's an error, you just say, please wait. So meaning eventually you have a response that comes back to here. If there's no response, just print, please wait, please wait, please wait, please wait. And every 30 seconds, you check again. Then you print, please wait, if there's no response. Eventually you get a response back, which is this. It just says pipeline execution display names and pipeline execution status succeeded, start time this, CPU time, this 30. So eventually it took 38 minutes. This pipeline execution steps, status after that. Okay, we have those. We list a bunch of our pipeline execution steps. Okay, so we have register model, create model, accuracy condition, evaluate model, train. Okay, so this actually starts from this. So processing steps right here. We have our train step right here, and we have the whether it's successful or not, and the timestamps. Then we have the evaluate model step. We have our accuracy condition, and it's, I believe it's succeeded. So it's succeeded, then we create a model. Yeah, we create a model, then we register the model. And that was it. So that was just listing all the pipeline execution steps and all the timestamps and the statuses. List all artifacts generated by the pipeline. So we're listing, okay, this is where the lineage comes in. And this is, I think this is very important. This is very, very helpful information for you to track your model. And this is where the trial, you know, why we define the trial and experiments, I guess. And we're calling the SageMaker.lineage.visualizer import lineage table visualizer. So, okay, and basically, for all the pipeline execution steps, we print the step first. And if the step name equals to processing, meaning if it's still well, if it's a step that's called processing, which is a data processing step, we'll print the processing job name. And we display the lineage within that step. If it's called the training step, we also display that. Else, we just show the execution step. So we don't need to show the condition step, I guess. Execution step. Well, actually, all the other steps are called execution step. Sorry. Yeah, so all the other steps are called, well, every step is called execution step because that's just a dummy variable in the for loop. And if the execution step is the data processing step, we do this and we show that. If it's training step, we do this. And if it's any other step, we just show them directly. So I assume this is the step name, data processing, and we have our lineage right here. Name source, S3, and we have a SageMaker this inputs and type image. So that's an image. SageMaker inputs. So there is an image here. So I don't see the image. Could this be the image? I don't know. Okay, so we can't really read this because it's omitted, but it is an image, container image, and we have a data set. Okay, we have our test data set, validation set, training set. That we all know, right? And this image could still probably be just in AWS own repository rather than something that we have our own, because it's SageMaker Scikit-learn CPU Pi3. It's very specific, and it's probably AWS's own repository, image repository. But all the other ones we have in our S3 buckets. And these two are the inputs. We have the outputs right here. So from this specific data processing step, right? And from the training step, we have the S3 right here, and input, data set, data set, data set. So we have our 3 data sets as inputs from the S3 bucket. Okay, we have our inputs as, okay, so this is very clear now. This is the image, the container image we spin up to process this job. We use SageMaker Scikit-learn 0.231 CPU PY3. And we used this instance to do that. Okay, instance type. And for this particular step, we spun up an instance using this particular image. It's called TensorFlow Training 2.3.1 CPU PY3.7. So meaning we're using TensorFlow and its version 2.3.1, and we're using a CPU, and we're using a Python 3.7. So meaning this instance type, this instance will have TensorFlow pre-installed, will have Python pre-installed, and it probably only has CPU, and it has a TensorFlow version of 2.3.1. And so that's the image that's being, Dockerized in that container. And we have our model outputted to this particular S3, and we just took a look at that, right? So that model output is in the right here. Okay, so yes, model output, the output for the model. And so we had 3 inputs and 1 image that's used to train this model, and we have our model outputted into S3. So that is what we mean by lineage. Okay, so it's tracing every step from the lens of input and output. Okay, so evaluate model. We have our direction, 4 inputs, 1 output. So evaluation, we're also using a container. Okay, we're using a container that's, again, it is SageMaker Scikit-learn 0.23.1 CPU Python 3. So it's using the same container image as this one, right? It's the same one. We have our input as evaluate model metrics. We have our input as the data set itself. We have our input as the model. Eventually, we have the, okay, so that was just this. If you recall, it's just this evaluate model metrics.py. Eventually, we have our model output, our outputs as metrics themselves. Okay, so this is eventually where we get all the metrics. And I believe this is I think we just looked at that. It was right here. That was the output from this step. Great. Eventually, we have our evaluation step. Accuracy condition step with a create model and register model. So we have 3 inputs. The model as inputs. And we have our image as TensorFlow inference. So now we're using a different image, container image, that will be deployed to an instance. I think it's deploy instance ml.c something 4x large, right? If you recall. I can't scroll down because this apparently has some bugs. I think we had trouble scrolling down for this too last time. All right, so but that is for inference. That image, that instance is for inference purposes. And we're using this particular model from this S3 bucket to inference that. And we have our pending approval status. Great. So if it's proved, great. Now we have our output into the model group. And I need to find out where this model group lies. Okay, it's probably in the, I would say it's probably in the, let's see, probably here. Yes, model packages, yes. Pipeline, model packages, not models. Does that match the name? Pipeline screen model. Reviews, no, it does not. Okay, we do have a bunch of models here, but model package group. Jobs. Okay, so we also have a bunch of processing jobs that's listed out here, which is also something for us to take a look at, which is cool. And we have additional metrics and logs right here that we can dig into. Processing jobs, this. Yes, that's great. And so great. So this provides further insight and monitoring capability for us to watch, right? And even the processing job. And as you can see, like you can even process this as data, to be honest. And debug, right? So this is how you can debug a lot of stuff, like seeing what the error message is and click into it, right? What's going on with this? Preparing transactions, collecting matplotlib, downloading progress, successfully installed. That's just installing libraries. Okay, and eventually you have this evaluation JSON and confusion matrix JSON, and you have a complete step. So that's, and this is probably the evaluation step, right? I would say. Okay, very cool, very cool. So we have our log groups right here. So we have our processing jobs right here and training jobs, bunch of training jobs logs. And this, again, under CloudWatch. Okay, CloudWatch is where I go for loads of debugging, and CloudTrail. CloudTrail is for resource deployment, debugging. CloudWatch is pretty much everything. And CloudWatch can help you to monitor as well. No GPUs detected. So because we remember we didn't use GPUs for training instance type. The ones that we chose didn't have GPUs. Test steps, validation steps. So those are a bunch of parameters we had for training. We're collecting the transformer 3.5.1. That's from the Hugging phase. We're installing library. That's all installing library. Okay, this is the Docker container part. Validation data, test data. So that's where all the data is saved in the container. Someone wants to say something?
I think you can also look at these CloudWatch logs from your command line. Also, there's a utility CW,
Yes.
which allows you to do that.
Yes, absolutely. Absolutely. Thank you. Thank you. Okay, we have some more data showing, and this is, yeah, this is probably features. Yeah, this is the feature groups. This is the feature groups. This is the model architecture. Okay, we have our input layer, total params, trainable params. I don't know why we had this. I thought we had 300,000. Could be wrong. Great. So those are all logs you can look at. Okay, and that's the lineage. At execution run is trial to experiments. Execution run is trial to experiments. Okay. We're just formatting here, associate trial components. Okay. Analyze SageMaker debug results. So let's look at some debug results. SageMaker estimator attach training job name. Let's look at what we had for training job name. It's this execution step. Got it. Okay. Let's look at the debugger output data. Debugger output, index events, collections, worker 0. Okay, that's some further debugging JSON file for you to dig through. Debug outputs. What else do we have? Events. We have a bunch of tf.tf events. That's probably directly from the TensorFlow model, I would say. Debug outputs. We have more JSON files. Let's download that. Model step. Okay, so that's not much useful stuff. What is this? .ts. No idea what this is. Okay. I thought it was going to be a report, but it was a bunch of file outputs, which is cool as well.
Reviewed in the report. So click on the review S3 debugger output report. Yeah.
But this just led me to the S3 bucket.
Oh, this one. Okay, so this one did. So which one was the? I opened the
profile report.
Profile. Well, profile report gave you what what we watched.
Yeah.
You got trust HTML top left, and we saw this. You also get the debug pipelines report. Bear with me. The link is on that notebook 7. here you go. Go to your pipelines to the menu on the far left row, all the way down. That, and then select not the pipelines. Go up on the drop down where it says pipelines to experiments and trials.
Okay.
Double click, open that, and open that trial, and take that first one. Yeah, that should give you the debug report.
Chart properties, line.
Mine looks a little different. I've got the SageMaker. What did I open? I've got the SageMaker debugger. It was the same thing. Pipelines. When you open that, mine looks a little different from what yours looks like. Can you
charts? You can add charts.
Can you open one from from 7 days ago? Your third on the list.
Yep. Third on the list.
Yeah.
Are you having the chart?
Yeah, mine looks different. Can I share screen?
Yeah, go ahead.
Okay, mine looks different. So when I opened the pipelines, I got this, and this seems to capture those text JSON output file reports.
Nice.
That's a lot cleaner.
Yeah,
I
agree.
And you can. I'm sure you can probably update it, but
I don't know what's going on my end.
Yeah. And given that you can select monitoring and profiling, this tells me you can do this in real time. Yeah, and monitor and profile your trained jobs in real time.
Yeah, I don't know why it's not showing on my end. Anyone else had this trouble? Can anyone else see what they got under experiments and trials on the left panel?
Yeah, I don't have that either.
Interesting. Okay. I think you just have to configure the chart. That's all. Oh, there you go. So I just configured it and it popped out. So
can you show your?
Yeah, you just have to configure this, and that's all. Charts. Yeah, that was all I had to do for this to pop out. But you already had it?
Correct.
That's interesting.
Yeah, mine was already fully done, but then I went through all of the notebooks last week. Tried to get, so I wonder if at one point I might have run something in a notebook that pre-populated those metrics, and so my debugger report had the charts, and there could be more, but this is the one they put in as default.
Yeah,
this is an interesting skill set. I hope you all might agree that this is more than just simple software engineering. This is a bit more operational as well. This is something, Terrence, I think you and I talked about this once. This is what modern day IT person needs to be able to do, because they're supporting the data engineers, they're supporting the model deployment, they're managing this part of the workflow, making sure that the model that's being deployed falls within certain parameters of what can be useful to the business. And there is a financial aspect to it, because you don't want it exceeding a certain level or failing or breaking, because that affects your business operations.
Agreed.
Like, it's one thing to say that fan companies, the Ubers, Facebooks, and so on, they may be 100% all this, but all companies are going to have to go into this. Yeah. Even if business of manufacturing widgets.
Yeah. 1 minute aggregation. Last 3 minutes. That's training average. I mean, I have the chart showing up, but for some reason, some data just can't show up. Which is weird. So batch variation accuracy last. Oh, because I have 9. Oh, that doesn't. Yeah, the time is right. There we go. I have no idea. Capture by running. You're doing training. Auto explainability. I would love some auto explainability. To run that, we have our bias report, trial mappings, debugger. Yeah, this entire thing needs to be. I definitely need to spend more time exploring this. This is cool. This is where everything is. Experiments and trials. And this is what it was, right? Experiments and trials, setting up the experiments and trials, and all that stuff. So it's all very, very good stuff. See, like you have this. Anyone else? Heather, do you have this chart showing up?
I did not, so I will maybe rerun my notebooks and see if I can get that working.
You have this, like, it's not showing up, right? Just like what I have in.
Yeah, like what you
Okay.
initially had. Exactly.
Okay. Yeah. All right. So Mesh must have done something that we didn't do. That's magical. So
No,
great.
I just don't know what I did.
All right, cool. I mean, that's pretty much it. I mean, I didn't realize I mean, I talked for another, I must have talked like 6 hours into this notebook. I don't know why this takes so long, but it is what it is. It literally took me 6 hours to walk through this notebook. And if it's finally done, so we can move towards the rest of the notebooks, which are like relatively straightforward, going forward. And I think Mash will talk some of this as he volunteered.
Yep.
Great,
Well,
awesome.
For what it's worth, Wen Chang, we really appreciate it. That was super helpful. So
Yeah.
Thank you.
Totally.
Yeah, thanks so much.
Yeah, no problem. I hope it was clear. I mean, a lot of stuff. Yeah, I try to explain some of the stuff in details because I know they only spent 20 minutes on this. So yeah, I hope it was clear. All right, so I guess we will continue with this and try to finish the rest of the notebooks. I'm pretty sure these are much easier to go through, and they can be done in one session. So we'll probably have one more session, and then I think we'll basically just talk what we want to do right after that. In terms of, should we go back to doing more TFX, or should we just spend more time just doing SageMaker pipelines and trying to get this for a real project and things like that? So
would the gang here be open to, we've done SageMaker, we've done basically AWS's version. We started with Google. We did AWS's SageMaker Studio and everything, full pipeline. Can we flip back to Google to look at Vertex and how they've extended the TensorFlow extended framework to make it a lot similar to SageMaker? And maybe depending on where we are, I mean, just basically what we're doing is staying at the very bleeding edge of machine learning engineering, ML ops CI/CD, all of that. To the extent that now all of us can probably talk through enough of this to get the serious jobs out there.
Yeah, I think that'd be a
Works
great
for
idea.
me.
Yeah, just think about it. Yeah, you all,
Yeah, sounds
all
good.
think about it. All right. Thank you, Wenchang.
All right, great. Sounds good. All right, have a good night, everyone. If you're in the region, if not, I guess good morning, good afternoon to you. All right, see you next week. Bye.